So we're going to do the product and the quotient rule. Start out with the product rule. If u and v are differentiable functions of x, then the product is also differentiable. And we can find the derivative of that product by this product rule. So the derivative of u times v is going to be the derivative of u times v plus u times the derivative with respect of x of v. Now, in shortcuts, we tend to use these prime notations in Calc 1 is it's the derivative of u or u prime times v plus u times v prime. So we'll do a couple examples of this product rule, but the first one I want to show you is that it actually works. So we'll multiply first, take its derivative, and then we'll do the product rule and see if these two derivatives match. So this is just verification of the product rule for you. So a lot of books will ask you to find the derivative in two ways just to reinforce this idea. So I'm giving you f of x, which is equal to 3x squared times that binomial 5x cubed plus 1. So the first way I want to do this is I want to expand it first. So we're going to multiply first, take the derivative second. And in part B, what we're going to do is we're going to take the derivative first and then simplify second. So if I have f of x, which is equal to 3x squared times 5x cubed plus 1, I can multiply this first. So f of x is going to be equal to 3x squared times 5x cubed is going to be 15x to the 5th. And then 3x squared times 1 is going to be equal to 3x squared. So this is still f, this is in its derivative. So now we can take the derivative with respect to x of f. So this 15x to the 5th plus 3x squared, and see what we get. So 5 times 15 is going to be 75. X to the 4th, dropped it by 1. 2 times 3 is 6, drop that power by 1, so 6x. Now, here we're going to use the product rule. So the derivative with respect to x of 3x squared times 5x cubed plus 1. So what we're going to do, the product rule says the derivative of the first, so we can write this as u, and this binomial here is going to be equal to v. So we know its derivative is going to be the derivative of the first times the second plus the first times the derivative of the second. Now, many books, they like to write this term first and this term second, but I prefer to do it in this order because when we get to the quotient rule, it's going to share that same order. It'll help us memorize it easier. So the derivative of the first, so we have 6x times the second, which is 5x cubed plus 1, plus the first, which is 3x squared, times the derivative of the second, so this is going to be 15x squared, and the derivative of 1 is going to be equal to 0. So simplifying this thing, we have 6 times 5 is going to be 30x to the 4th plus 6x, and then 3 times 15 is going to be 45x to the 4th. And then when we add our 30 and 45, we get the exact same expression of 75x to the 4th plus 6x. Now I know you probably ask is, why do we go through the product rule? Because it looks more complicated. Well, in this case it is. It's easy to multiply polynomials. So many times you'll just multiply the polynomial first and take its derivative second. But there are expressions out there that it's easier to do the product rule than it is to multiply, or really it's the only way to find its derivative. So we'll do a couple of other examples of this product rule, and then we'll move on to that quotient. So we're going to use the product rule to find the derivative of these two functions. So I know this is polynomials, and it might be easier just to multiply it first and take the derivative second, but I'm really trying to practice this, this product rule. So what I like to do is I like to label these things. So we're going to label, this function right here is going to be u, that binomial, and this binomial over here is going to be v. So I know that its derivative, or I can say f prime of x, its derivative is going to be the derivative of the first times the second plus the first times the derivative of the second. So the derivative of x squared plus 1 is going to be 2x, because the derivative of 1 is 0, times the second, so this is going to be 3x squared minus 5x, plus the first, which is going to be equal to x squared plus 1, times the derivative of the second, which is going to be, this is going to be 6x minus 5. That is the derivative. Many times we want to simplify this, so I will expand and simplify. So 2x times 3x squared is going to be 6x cubed. 2x has minus 5x is minus 10x squared. Here I have a binomial over a binomial, so I have to FOIL this. So x squared times 6x is going to be 6x cubed. Outside's minus 5x squared. Inside's plus 6x, and last is going to be minus 5. Then we can combine any like terms. So the cubes will add to a 12x cubed. The squares will add to a minus 15x squared. There's only one linear term, so plus 6x, and then we have our minus 5. Now, this is kind of the example to where you can't multiply that. That's it doesn't expand any nicer than this. So if I want f prime of x here, sure I can fit it. If I want f prime of x there, I know I'm going to have to take, well, this is going to be u prime v plus u v prime, this function being u and this function being v. So the derivative of the first, well, the derivative of x is going to be 1 times the second, which is e to the x, plus the first, which is going to be x, times the derivative of the second. And the derivative of e to the x is one of our favorites because the derivative of e to the x is e to the x. So this will simplify to e to the x plus x e to the x. So that's the derivative of that product. So 2 more examples for the product rule. We'll move on to the quotient. So we'll take the derivative of these 2 products. So again, this is going to be u, this is going to be times, this binomial is going to be v. So f prime of x is going to be the derivative of the first. Now, notice that u is the same thing as x to the negative 1. So let's just rewrite that. So this is going to be x to the negative 1 multiplied by x squared plus 4. And let's rewrite this one as well as x to the 1/2 power. It'll be easier if we write them as base to power. So f prime of x is going to be equal to this u prime v plus u v prime. So the derivative of x to the negative 1 is going to be minus x to the negative 2 times the second, x squared plus 4 x to the 1/2 plus the first, so this is going to be x to the negative 1 times the derivative of the second, which is going to be 2x, and then the derivative of this is going to be 1/2 times 4, which is going to be 2, and I have to drop that power by 1, so this is negative 1/2. Now we can rewrite these and simplify. I don't think I'm going to expand them. I'm just going to rewrite them back into their original form. So this is minus 1 over x squared multiplied by x squared plus 4 root x. Plus this is going to be 1 over x times 2x plus, well, this is going to be a square root on the bottom, but that 2 is still to a positive 1 power. So this is in the numerator, this is in the denominator. Now, of course, we can distribute and simplify, add these powers and so on. But really, we're just trying to practice that product rule here. So the next one, we'll slide over here. The next one is going to be f of x, which is equal to x e to the x sine of x. So that'll be our next example. So if I want to find the derivative of this thing, again, this is one where we can't multiply first. This is as nice as it gets. So this is going to be our u times our v. So f prime of x is going to be u prime v plus u v prime. So the derivative of e to the x is e to the x times the second, so sine of x, plus the first, which is going to be e to the x, times the derivative of the second, and we know the derivative of the sine of x is going to be equal to cosine of x. I know you can factor out an e to the x, but really this is the derivative of that product.